Hello guys, this is Paul McWhorter from TopTechBoy.com, and we are here today with lesson number 16 in our incredible new tutorial series where you are learning artificial intelligence on the Jetson Nano. I will need you to pour yourself a most excellent cup of iced coffee. Cup? What am I thinking? This is an enormous mug of iced coffee. And I will need you to get out your Jetson Nano gear. Hey, want to take a second and thank you guys who are helping me out over on Patreon. It's a huge encouragement to me to have you guys become an active member of this channel. If you haven't done that yet, look in the description down below. There's a link that'll take you over to my Patreon account, and the help that you give me over there helps me continue to keep my studio equipment up to date, modern gear, and all that sort of stuff. But enough of this shameless self-promotion. Let's jump in and talk about what we are going to do today. I do believe that I left you with a homework assignment last week, and that homework assignment was to open your camera, to fire off your camera in OpenCV, and then draw a box and have that box bounce around the screen on top of live video. I told you that you had all the tools that you needed in order to make that work, and then I gave you this quick little demonstration of what I wanted you to do. Okay, boom, there it is. You see the happy little red box hits the bottom, bounces up. I've done the homework already. You guys leave me a message. How many of you were able to do this homework? How many at least tried and failed? Or how many actually took the Jetson Nano and threw it out into the street after trying to figure this thing out? Okay, actually I like giving homework assignments like this because this is kind of like a classic problem, and it's something you've got to be able to think through, and it really helps you build and develop your programming skills. And so the thing that I tell my students is a program like this actually turns out to be really simple if you have a roadmap and if you kind of sketch it out. But what I tell my students, and I'll tell you, you want to get it working on paper before you try to get it working on code. And too many times we jump in and just start trying to bang out code, and then it just gets hopelessly confusing. We need a clear picture. We need a clear roadmap of how we are going to do this. So I will show you what my strategy is. Be sure and leave me a comment down below about whether you were successful or not. And I do believe that I need to scoot over here to a different window. Let's see if this one looks good. Oh, okay, that one looks good. And there is my green screen not working real well. Okay, that looks pretty good. All right, so let me get out of your way, and let's think about this problem, and let's see if we can come up with a strategy to solve it. The first thing we have to think about is we have a screen. So what should I do? I should probably draw that screen. Okay, so that's the top edge of the screen. Okay, then I will come down here and I will draw the bottom edge of the screen. Okay, and then connecting the top and the bottom will be the left side of the screen. Okay, and then coming over here will be the right side of the screen. Okay, and that is somewhat of a square box. I am gonna do that again because that is not good enough to make me happy. So I will come over here and I'm going to clear that. And kind of the mistake that I made was, there it is. The mistake I made was I was not using a good pen and it was too thin. So let me get a good pen. We'll get this thing going. Okay, so we are going to draw the bottom of your display screen. We are going to draw the left side of your display screen as such. We will draw the top up here. And you guys seriously do this with a nice ruler, you know, make it kind of nice and neat as you can. And so now this is your screen. Look at that. I am pretty happy with that. Now what I need to call this up here, I am going to call this, I'm going to call this display, D-I-S-P-W. Okay, across there is the display width. And then you guessed it, over here, we will call this display height. Okay, so you're going to have a box that is your image, and it is some pixels wide and it is some pixels high. Okay, now what's the other thing we know? We know that this point up here is the point 0, 0. So we need to kind of keep that in mind, and I will get out of your way further before you start yelling at me. You know, sometimes I lose my mouse. There it is. All right. So then down here we would know that this point would be the point what? Well, it's the point display W, comma, display height. So you see how I'm trying to kind of set up a coordinate system? That was pretty ugly, but display width and display height. All right. Now what are we going to have? We're going to have a rectangle that is going to be bouncing around. So I need to draw that rectangle, and I need to kind of label it. Okay, so here comes my rectangle. All right. Now this is this hypothetical rectangle that we are going to have running around. And then we need to kind of give a position. Remember that rectangle command in OpenCV? You remember how that works? You want a coordinate for the upper left and a coordinate for the bottom right of the rectangle. So I'm going to call this point, I'm going to call it X pos for X position, because that is what actually puts the rectangle in a position. And then I'm going to call it Y pos for Y position. Okay, so now I have a coordinate for the bouncing rectangle. Then what do I want to do? Well, I think I'm going to call this box width, all right, from here to here, like, you know, across here is box width, and then this is box height, all right? Now, this then, we need to think, what is this coordinate? This coordinate would be X position plus box width, comma, Y position plus box height. Okay, does that make sense? I think that makes sense. So now I've got the two corners of the screen, and I've got the two corners of the rectangle that is going to be moving. Now I got to start kind of thinking about moving. Well, the position is always going to be the same. The position is X pos and Y pos. And so what I have to do is, to make the box move, as I'm going through the loop, I've just got to change X pos and Y pos. So what I think I will do is I will say that X pos is equal to X pos plus dx. Okay, so the X position every time through the loop is going to be changed by the number dx. And then what I can do is I can come over here and I can say Y pos is equal to Y pos plus what? dy. Because I got to keep two different things, because I might be going left, I might be going right. That is going to be the dx. I might be going up and down. That is the dy. So to keep track of this motion, I've got to know where I am, and I've got to increment it by some amount in x and increment it in some amount in y. Now I'm going to have to think about some if statements. And what I see is, I'll do one for you, and then you can kind of see how it works. What do I want to do? Well, when this edge of the rectangle hits the right edge of the screen, well, what would that be? That would be if what? X pos plus BW, right? That's this side here. If that is greater than display width. If it's greater than display width, then what do I want to do? I want to say dx is equal to dx times minus 1. Okay, dx is equal to dx times minus 1. So if I'm going in this direction, I'm going in the positive direction, and I hit the wall, I multiply by -1, and then it's going to go in the negative direction. If I'm going in the negative direction, dx is negative. If it hits the other wall, then a negative times a negative is going to be a positive. So with this simple if statement, I'm going to take care of the right wall. But then what I also have to think about is I've also got to say, or if x pos is less than or equal to 0, then I want to make it change in the other direction. So dx would be dx times minus 1 again. And so really I'll have one if statement for the left and right and one if statement for the top and bottom. And I believe with two if statements we can solve this whole thing. Now, does this make sense what I'm talking about? This is going to move in this direction till it hits the wall. Then the direction is going to change and it's going to come back. It's going to go here until it hits a wall, and then it's going to go here. So this side I would compare to this side, I would compare to this edge, this side to this edge, this side to this edge, and this side to this edge. But I can do that with two if statements, with each if statement having two conditionals. Do you guys see what I mean about needing to have a strategy and needing to have a roadmap? And so let me come back over and let's call up our Jetson Nano and let's see if we can switch over to that, and then let's see if I can make some magic happen here. Okay, so what we need to do is open up our Visual Studio, and I will pop mine open here. Let me make sure. There we go. All right. And then remember that we have this OpenCV .py, which is basically the simple program that fires the camera up. And that's always our starting point. If you don't have that yet, you can come over here to the most excellent www.toptechboy.com. You can hit search. The little search icon, search on Raspberry Pi camera or web camera on the Jetson Nano, and you will get to this. And then you will get this starting code, which you can come here, click on the two little boxes, and then right mouse click, and then copy. Let me try that again. Make sure I get it. Right mouse click, copy. And then what I will do is I will move this out of the way. And now over here in OpenCV, remember you got your OpenCV folder. You're going to click on that, and then you're going to come up and say plus. And what you are going to add is you are going to add the program. We'll call it OpenCV. And the last one we did, I think, was 4. So we'll call this OpenCV 5, and then bounce box.py. Okay, let's see if that works. Boom, here we are. Now what we'll do is we'll come in and we will paste that code that we got, and now we've got to just configure this for the camera that we're using. And I'm using the Raspberry Pi camera, and so I want to uncomment out this line that says cam set, and that gives the string needed to fire off the Raspberry Pi camera. And then this cam is equal to cv2.video capture, and send it that cam set string. That is pretty straightforward. If you are using a webcam, you would uncomment this line, and then your parameter here would either need to be 0 or 1, and that should fire off the webcam. And so that is getting us where we need to be. Okay, so now what we need to do is we need to start writing this program. All right, so what I am going to do is I am going to come in and I'm going to start thinking up here about setting up that rectangle, right? I want to set up that rectangle. So one thing is, this is kind of a new command. You really don't need it, but if you are, I'm going to use it for the Raspberry Pi camera, but you don't really need it for the Raspberry Pi camera. But if you're using the webcam, you need to grab from the webcam to make sure that you know how big that box is, how big your display window is. And you can get that by saying display window. Display window is equal to, you got to change it to an integer, and then you're going to do cam.get. So you're going to get from the camera. What are you going to get? cv2 dot, and then cap, and then underscore, and then prop, okay, and then underscore, and then cap prop, and then frame, okay, and then underscore width, okay. And let me make sure that you can see that whole thing. Yeah, cv2.cap prop frame width. All right, so that should get from the camera what the display width is. Now this is kind of silly for the Raspberry Pi camera because we already sent it to it and now we're just asking for it back. We can probably, I think the easiest thing would be to copy this line. So I'm going to copy this line, Control C, come down here, and then I'm going to paste. And now instead of display width, we're going to say display height. And then we will come over, and this will be, instead of frame width, this will be frame height, all uppercase. Okay, and I better get a little further out of your way so you can see. Okay, so now we should know that window size, right? The big box size, we should know that at this point. All right, now we need the little box size. Well, think about it. Your screen window, your display window might be great big, it might be little small. And so you don't want to use a fixed rectangle size. You want to proportion your rectangle to the size of the overall screen. And so I think what I'm going to say is the box width is going to be equal to the integer value of 0.15 times display width. Okay, I kind of like that. And then no, I'm going to make it 0.25. I'm going to make it 0.2. Right, 0.2. All right, and then I'm going to make the box height. I'm going to make that integer, and I'm going to make that more like 0.2. I'm going to make it 0.25, and then this one up here I'm going to make 0.15. How about that? Okay, 0.25 times what? That would be display height. All right, does that make sense? So that rectangle is always going to be proportional to the size of the window. Change the size of the window, it changes and it looks good. This is kind of like what I would call parametric design, that you're designing your visual around parameters, and that way if you change one thing, it should change things in proportion. And so it's kind of a neat programming technique that we will be using. So that really looks pretty good. Now we've got to start it somewhere, right? Where are you going to start it? Well, I'll say pos x is equal to 10. And then I'll say pos y is equal to 270. So that means the upper left corner of the rectangle will start at an x value of 10 over and a y value of 270 down. Also, that dx, remember how much we want to change as we go through each frame? Well, I'll just say dx is equal to 2, which means it will start out going in the positive x direction. And then I will say dy is equal to 2, which means it will start going in the down direction by 2. Now, these things will change. You should hit the wall, but you got to kind of seed the thing to get it going. I think that is pretty good. And then I will get rid of this useless blank lines there. Now, what are we going to do in the program itself? Well, we are going to grab a frame. We're going to show the frame. And you know how I always like to have my frames in good spots. So I'm going to do a I'm going to do a CV2.moveWindow. And then where am I going to move the window? The window that we are using is Nano Cam, right, as you can see in the upper thing. And then where do I want to move it to? I want to move its upper left corner to my screen, position 0, 0. All right, now that looks pretty darn good. Okay, now what I've got to do is I got to put my rectangle on there. So I've grabbed a frame, I've shown the frame, and now what do I want to do? I want to add a rectangle to it. So how would I do that? You know from last time, its frame is equal to CV2.rectangle. And then where is it going to be? Well, first of all, it's going to be the frame. Kind of silly, you got to tell it twice. And then what is the upper left corner of the rectangle? Go back and look at that picture we did. It's pos x, comma, pos y, all right, and that's a tuple. That x and y coordinate are inside of parentheses. Then what's the bottom right? Well, it's pos x plus what? Box width. Go back and look at the picture, and these need to be in parentheses too. So it's pos x plus box width, and then it is pos y plus box height. Does that make sense? Man, I really, really, really hope that makes sense. I hope that makes a lot of sense. Go back and look at the picture. Now we got to give it a color. So let's just say, let's make it blue, which would be 255, 0, comma 0, because remember that OpenCV works in blue, green, red, kind of backwards to what we normally work, red, green, blue. And then we got to give it a line thickness. Well, I'm going to say like a 5 there, okay? Add that. I think I made a solid box on the demo, so I better make it -1. Okay, that looks good. Okay, and now just for good measure, I really think that I should show it after I built it. So I'm going to take this and I'm going to cut it if I can. I'm going to cut that line. I'm going to kind of build it before I show it. It'll really work either way, but just good measure. Okay, so I put the rectangle and then I show it. I think that looks pretty good. Okay, so now we're going to have a rectangle, right? But what do we want to do? Every time through, we want to change the position. Well, how do we do that? Pos x is equal to pos x plus dx, right? And then what do? We're going to say pos y is equal to pos y plus dy. Did I use little x's, or I guess I better go up and see, did I use? Yeah, I used little dx, little dy. Okay, got to make sure you're doing these things right or the box won't move. Okay, so now every time it's going to move the box a little bit, okay? And so it's as simple as that. But if I just ran this now, maybe we should run it now. What's going to happen? That box is going to jailbreak, right? That box is going to jailbreak. Are we able to run this? What's going on? Maybe I have an error. Well, if I have an error, we probably should figure it out now. Oh, okay, it doesn't like line 12. Display height is not defined. What is this nonsense? Uppercase D. Did you guys see that? And were you, in fact, screaming at me? Okay, so now let's right mouse click, run Python file in terminal. Oh, look at that. Boom. Jailbreak, jailbreak, jailbreak. Okay, why? It's just going to go on forever. We got to put those if statements in there to change dx if it hits a place that it shouldn't. Okay, so now that is going to be 2. Let me see if I can go back and just remind you what we're looking at here by coming, I do believe, to maybe this one. Is it this one? Okay, yeah, that one looks pretty good. Okay, so remember what we are looking at. We are looking for the point that, actually, I'm looking for my stylus, which I have lost, unfortunately. There it is. Okay, so what happens? We want to look where this edge hits this edge. So where this edge hits this edge, when this edge hits this edge, when this edge hits this edge, when this edge hits this edge. So we've just got to be careful in the way that we construct our if statement, right? We just got to be careful in the way that we construct our if statement. But we just need to do some if statements here, and then we should be in excellent, excellent shape to get this thing working. So I need to come back over here. All right, so now we need to work on our if statements. And again, if we're careful, we can do it with 2 if statements. And really, it's better to do it with 2. And the more you do, the more complicated it's going to get. And so what do we care about? We could care if position x, that's that upper left corner, if that becomes less than or equal to 0, we want to change direction, or we'll have a what? We'll have a jailbreak on our hands. Okay, we will have a jailbreak on our hands. So that's one condition we'll want to change. Okay, and then besides that, we want to say, or the other x condition, or if pos x is greater than that other x value. And what is that other x value? That other x value, I'm sorry, we're looking at the corner of the box, and so it's pos x plus the box width. If pos x plus the box width, that is that corner, if that is what? Greater than or equal to display width. So if that right side of the box gets to the right side of the screen, we better what? We better put a colon for an if statement, and then we say dx equal dx times minus 1. And you see, this always is going to work. I'm going to put parentheses just for good measure there. This is always going to work, because if I'm going positive, I want it to be negative. If I'm going negative, I want it to be positive. So if I multiply by -1, it'll always work. It is as simple as that. Okay, now we want to do another if statement, and so we're going to say if. Now we got to deal with the up and down. So what we are going to say is if pos y, and what will this be? If it is less than or equal to 0, what are we going to do? We're going to make it the dy -1. But there's another condition, and that other condition is if pos y plus box height, if that is greater than what? If that is greater than what? Can you tell me? If that is greater than display height, then what do we want to do? dy is equal to dy times, open parentheses, -1. All right. So that's just saying, if the right edge hits the right wall, change direction. If the left edge hits the left wall, change direction. If the up of the box hits the top, change direction. If the bottom of the rectangle hits the bottom, then change direction, right? And so this is really pretty incredibly simple code. So let's see if we can run this thing. We are waiting on pins and needles, and I've got a very bad feeling we made a mistake here. Oh my goodness. I didn't finish that. Were you guys yelling at me? If pos y is less than, it should be less than or equal to 0. I did some crazy programming there. Let's try it again. Boom! Bouncing off the bottom. Okay, let's watch. Let's watch. Here it comes. Is it going to jailbreak? Boom! Bouncing off the top. Bouncing off the right. I'm not sure we've seen it bounce off the left wall yet, so let's make sure. Boom! Okay, one more. Boom. Is that not magic? Can you believe that this is working with that simple of a code? One thing I don't like, how did I do that crazy rectangle that it is those crazy dimensions? I was thinking it would be left and right. Okay, width, oh my goodness, width should be 0.2. Let's make width 0.25, and let's make the height 0.15. Okay, I'm sorry, let me turn my phone off. Okay, I will turn my phone off. Okay, that should not bother us again. Okay, so that should look very good there. And so what we are going to do now is we are going to run the file, and this should look a little better. Okay, that looks good. So we're coming, boom. Okay. All right, guys, this looks really good. I am really excited about this. Let me know, were you guys successful in writing this program? Or did you have trouble with it? Okay, let me know if this worked out for you or how much trouble you had. Okay, really appreciate it. If you guys like this lesson, think about giving us a thumbs up. Think about stopping by our Patreon account. Think about sharing this video with others. Paul McWhorter from TopTechBoy.com. We'll talk to you later.